differential equation by using the method of differential equation. Now the question is, there are many methods to solve the differential equation. So which method we must use to get the solution? So if you see the form of the differential equation, then it is given in the form m dx plus n dy equal to 0. So we know that if the equation is in this format and if the value of dou m by dou y is equal to dou n by dou x, then that equation is exact and we can get the solution by exact differential equation. So first of all, we need to check whether it is exact or not. So for that, here I'll say comparing with m dx plus n dy equal to 0. So here we'll get the value of m as 2x hyperbolic sine of y upon x plus 3y hyperbolic cos of y by x. Now the value of n is nothing but minus 3x hyperbolic cos y upon x. So now let's take the value of dou m upon dou y and dou n upon dou x. So for dou m by dou y, I'll differentiate this m with respect to y partially. So 2x constant outside, the derivative of hyperbolic sine is hyperbolic cos y by x, and again the derivative of this y by x with respect to y partially is 1 upon x. Next, plus to differentiate the second term with respect to y, in both the functions we have y. So here we have to use the rule of u into v. So guys, here y as it is, derivative of hyperbolic cos y is hyperbolic sine y by x into 1 by x plus hyperbolic cos y by x as it is, and the derivative of y is 1. Now here I can cancel this x term, so we will get 2 times hyperbolic cos y by x. Similarly, if I'll multiply the second term with this 3, I'll get 3 times hyperbolic cos y by x. So this together will become 5 times hyperbolic cos of y by x. Here we will get plus 3y upon x hyperbolic sine of y by x. So guys, this is the value of dou m by dou y. Now let's find out dou n by dou x. So therefore, dou n upon dou x is equal to, so this minus 3 is constant outside, and here again I'll apply the rule of uv. So minus 3, and in bracket we will get x as it is. For hyperbolic cos y by x, the derivative is hyperbolic sine y by x, then y constant, and the derivative of 1 upon x is minus 1 upon x squared. Next, plus hyperbolic cos y by x as it is, and the derivative of x is 1. So by multiplying with minus 3 and by cancelling this x, we'll get minus minus positive 3y upon x into hyperbolic sine of y by x, and this term is minus 3 hyperbolic cos y by x. So this is the value of dou n by dou x. Now guys, let's observe the value of dou n by dou x and dou m by dou y. So they are not equal. So therefore I'll say dou m upon dou y is not equal to dou n upon dou x, and therefore the given differential equation is not exact. So now it's clear that the given differential equation is not exact, and hence we cannot find out the solution of this given differential equation by the method of exact differential equation. So now question is, which method we must use, or can we convert this given equation, given differential equation to exact? Then the answer is yes. So how should we convert the given differential equation to exact? So it's simple, that if we find the integrating factor and if we multiply the given differential equation with the integrating factor, then we can convert any given differential equation to exact differential equation. And to find the integrating factor, our equation must match with certain patterns which are reducible to exact. So guys, here I have one more pattern which says if the value of dou m by dou y minus dou n by dou x whole upon n is equal to function of x, then this can be the integrating factor by which we can multiply the given differential equation. And similarly, I have one more pattern, and here we have two more patterns. So we just have to check that which pattern it is matching with. So if it matches with any of the pattern, then we will use it and we'll find the integrating factor respectively. So let's check for this pattern 3. So the value of dou m by dou y minus dou n by dou x upon n should be f of x. So guys, remember that since we have these 4 different types by which we can reduce the equation to exact by getting the integrating factor, in the examination you have to always compare your differential equation with all these 4 patterns. So right now I am matching it with pattern number 3. So for that I have to subtract this dou n by dou x from dou m by dou y. So guys, here I'll say therefore dou m upon dou y minus dou n upon dou x upon x equal to. So this is the value of dou n upon dou x and this is the value of dou m upon dou y. So this value minus second value. So 5 hyperbolic cos y by x minus of 3. So that will become 8 times hyperbolic cos of y by x. Next, here we have 3y by x sin h y by x minus 3y by x hyperbolic sin y by x. So that will be cancelled. In the denominator, here we have to take the value of n and not the value of x. So here I'll say it is the value of n. So the value of n here is minus 3x hyperbolic cos y by x. So here I'll write down minus 3x hyperbolic cos y by x. Now guys, here we can cancel this hyperbolic cos y by x and we will get minus 8 upon 3x, which is function of x. So it is exactly matching with the form 3. So therefore we will say the integrating factor is e raised to integration of f of x dx, which is equal to e raised to integration of minus 8 upon 3x dx. So I can take this minus 8 upon 3 outside and the integration of 1 upon x is log x. So this will become e raised to log of x raised to minus 8 upon 3 and then e and log will be cancelled. So we will get x raised to minus 8 upon 3, which is equivalent to 1 upon x raised to 8 by 3. So guys, this is the integrating factor that we got, and if we multiply the given differential equation with this integrating factor, then it gets converted into exact and then we get the solution by exact differential equation. So here I'll say, so multiplying this equation by 1 upon x raised to 8 by 3, we will get in bracket 2 x hyperbolic sin y by x upon x raised to 8 by 3. So that will go up and this will become x raised to 1 minus 8 by 3. So which is x raised to minus 5 by 3 hyperbolic sin y by x. Here we will get plus 3y x raised to minus 8 by 3 hyperbolic cos y by x dx. Next, here by multiplying it with 1 upon x raised to 8 by 3, we will get minus 3 x raised to minus 5 by 3 hyperbolic cos y by x dy equal to 0. So now guys, by multiplying the equation, given differential equation with the integrating factor, we have converted the equation in exact differential equation. Now let's get this solution. So the solution of exact differential equation is given by, this is the formula, that is integration m dx plus integration n dy equal to c. Now guys, here this is the value of m, and if I try to integrate this with respect to x, then that is difficult, or here it will lead to a complex term. So instead of integrating m with respect to x and then n with respect to y, what we'll do is we will first integrate n with respect to y, where we will consider x as constant, and then we'll integrate m with respect to x, where we will consider the terms which are free from y. So here I'll say, therefore its solution is given by, so first of all I'm writing the formula. So integration of n dy by treating x constant plus integration of m dx equal to c, and here considering the terms which are free from y. By using this rule to get the solution of differential equation, we will get integration of n dy. So here the value of n is this, so I'll say minus 3 x raised to minus 5 upon 3 hyperbolic cos of y by x dy, and to integrate m with respect to x, we will consider the terms which are free from y. So this is the value of m, and in this value of m, this first term has y as well as the second term includes y. So there is no term which is free from y. So I'll say it is plus integration of 0 dx equal to c. So guys, by integrating this, minus 3 is outside, we have to consider x as constant, so x raised to minus 5 by 3 is constant, which is outside, and integration of hyperbolic cos is hyperbolic sine y by x divided by, again the derivative of y by x with respect to y will be 1 by x. Here we will get 0 is equal to c. Now this x will go in numerator, that will become minus 3 x raised to minus 5 by 3 plus 1, and that will become minus 2 by 3 into hyperbolic sine y by x equal to c. So guys, this is the solution of given differential equation, and we got this solution by using or by reducing the given differential equation to exact. So I'm sure that you understood this video and you want to learn more videos on engineering mathematics. Then do not wait. Log into ekeeda.com today itself, where you can get access to all engineering videos at one place. So thank you very much. All the best.